everyone, and we're back with Practice Forward. Today, we're speaking with Jesse Louis-Rosenberg, who's a kind of generative spatial artist and designer, and he has a company called Nervous System. Welcome to the show, Jesse.
Thanks for having me.
It's great to be with you today. So this is the Practice Forward podcast. We're sponsored by Scan-to-Plan. We're the Scan-to-BIM team that can measure and model any building in weeks, and we're the standard of excellence. So please feel free to get in touch. We're at scantoplan.io. So Jesse, I've been sort of following your work for years, and it's really I feel like you've been very influential in a lot of generative design. I guess we could call it maybe biomimicry, or just to give people a feel for Jesse's work. It's a lot of, I guess, code-based generative design principles that result in work that looks like different kinds of maybe cellular structures, microscopic kind of forms, very sort of biophilic type textures. Tell me a little more about this, Jesse.
Sure, I can give you a little introduction. I mean, in the broadest sense, I would say that Nervous System is a design studio that focuses on like taking computational design and digital fabrication to create one-of-a-kind and customized products, art, and even sort of do biomedical research as well. And yeah, we focus mostly on sort of looking at how structures form in natural systems and sort of turning those into kind of computational workflows for design. So we look at things like the way that veins form in leaves and these cellular structures from radiolarians, which have been inspirational to countless designers since sort of Ernst Haeckel's early microscopic drawings, and looking at systems from biological to sort of more chemical, physical things like crack formation. But we're really sort of interested not necessarily in kind of mimicking those structures, but kind of using them as an inspiration for understanding ways we can kind of sculpt, form, and pattern in procedural ways.
Very interesting. And and then your work spans everything from, small things like puzzles and jewelry, all the way to other things that are much more sculptural and architectural at scale. And so you've done a couple pretty interesting installations recently. I know there's one I've seen at the airport here in Albany. Tell me about some of the larger scale sculptural work you've been doing.
Yeah, so recently we've been doing some larger scale work. We've worked on things as small as 3D printed tissues that are, smaller than a dime. And the largest things we've worked on a sculptural installation in a 120-foot tall atrium that sort of spanned from the floor to the roof. And we've also done some sort of architectural paneling for sort of both like interior ornamental things as well as exterior paneling. And then recently we've been working on a number of sort of standalone sculptural projects like the one you saw in Albany Airport, sort of similar ones that are made out of riveted flat panels
Mhm.
where kind of the entire structure is determined by the panels and how they connect. So the whole thing, the sort of concept is that we take a surface and we cut it up into sort of little pieces and flatten them, and then sort of the entire thing can be assembled just from those panels. So the panels have labels on them which tell you how to connect them,
Mhm.
and by connecting them, you build sort of a complex 3D form where there's no form work or sort of forming tools. It can all be assembled by hand into a large three-dimensional structure.
Right. Yeah, I know. And I saw that, like, it's interesting with a lot of the panels. So these are like laser milled or laser cut panels, something like that. But
Yeah,
uh,
laser cutting
so,
them.
so there was a really incredible railing that you did, and what's so amazing is how the light passes through all these different. So these railings kind of look like cellular arrays, I guess, cellular. Um, well, I don't know. Let's talk a bit about the. Uh, seems like in your studio you don't really use pencil or sketching or any. Do you guys ever work with any kind of more other non-digital media before you're fabricating? I mean, does everything just come out of code?
Yeah, so our primary workflow is that we write our own code from scratch for sort of every project has its own sort of code base. Not
Mhm.
necessarily the most efficient way to work. You know,
About it, yeah.
most people either work with software that is off the shelf or at least sort of have built up some sort of suite of tools over time that all works together.
Yeah.
We usually are sort of starting over from scratch, which, both puts a lot of upfront work, but also gives a lot of flexibility in how we work. And, I mean, like anybody, we sort of will sketch things on a little notepad, but we're not very good at drawing. Uh, our sketches aren't really meant to be like, let's try to make this thing. It's more sort of getting a concept down and trying to communicate it with each other.
Yeah, I can understand. And it's amazing to just, be able to leverage all this existing stuff that exists in nature and mathematics and visualize it. It's amazing. So you before you nervous system, you worked at Gehry Technologies. How did that shape did that shape any of the work that you do now, or what were you doing exactly when you were working there? What was that process like?
Working there was certainly interesting. And I don't know if it really shaped what we're doing now at nervous system. I mean, we had actually started nervous system before I
Uh-huh.
started working at Gehry Tech,
Sure.
but it was still sort of a side project. But it was definitely an interesting look inside of sort of the architecture industry
Yeah.
and how things get made. I was sort of embedded into different projects, kind of as you could call it like a little SWAT team that is like, we need some extra automation to speed up some sort of process.
Right.
So sort of putting out fires in a way of like looking for ways to accelerate or automate tasks that were taking too long by hand.
Sure. Sure. Yeah.
One of the interesting things about Gary's practice at the time, at least, this was in like 2007,
Hmm.
a while ago, is, you know, none of the design work was digital. All the design work was done by model building, very model building focused. And so the digital work was all sort of figuring out how to build those things. And
Yes.
also a lot of the work was sort of taking those designs and then fitting them into a programmatic plan. So there'd be a lot of things like, oh, we need to change the mix of this property from like 50-50 residential commercial to 40-60, and having to completely redo some thousands of units is a lot of manual work. And so we would create ways to accelerate those sort of processes, which are actually much further down in the sort of design process than sort of what I mostly work on now, which is like more working on the conceptual side of things than the
not nearly as logistically challenging as some of these Gehry buildings, I would imagine. So what draws you and your partner into translating natural growth systems into generative workflows?
Well, so we were both students at MIT, and I studied math and computer science, and Jessica studied biology and architecture.
Mm-hmm.
And we were both just kind of misfits, I would say, in our fields. I mean, especially at the time in the early 2000s, sort of computation in architecture was still looked at very skeptically.
Right.
And so Jessica had done some work in John Maida's group at the Media Lab, which is called Aesthetics and Computation. They had built sort of an early version of the software that became processing, which is now a very common computational tool for artists and designers. And so she, had originally been studying biology, and through this work in John Maida's group, got more interested in art and computation, which then led her into architecture, because at MIT there isn't really any art program. So in order to pursue those ideas, she went into architecture. And then I sort of got drawn into that world from the math world, and our work just sort of grew out of combining all of the things that we were interested in. I was really interested in sort of complex systems, and also sort of very early on, I was interested in things like neural networks and artificial intelligence, which are all the rage now. But at the time, we're very much on the outs. Neural networks were not cool at all in computer science in the early 2000s.
Yeah.
So when I was working in artificial intelligence labs at MIT as an undergraduate, I became sort of very disillusioned with that world, and sort of found my way into doing more sort of art and architecture focused work.
Yeah. Well, it sounds like you guys have found a really great blend of being able to mix, these kind of high profile public artworks with some kind of custom architectural work, and then your products. So you've actually made some public facing tools for design where people can go to your website and actually use your generative tools to make their own custom designs, which is really great. And that you actually make that affordable for people, because I've seen projects like this that have always been, insanely expensive. But some of the tools that you've made, it's great that you can really design your own interactive necklaces and jewelry and other things on the website. Have you thought about doing anything like that might work with architects, like making panels for Revit or I don't know, creating something where people could drop in like a custom nervous system panel into their house?
Yeah, I mean, we'd certainly be interested in doing that and up for that. But the architecture world has a bit more overhead in terms of getting projects started. I mean, we're doing, some work for a couple architecture projects right now, and they started like over 2 years ago and are
Yeah,
now just getting into fabrication. So
sure.
it's a time scale that's kind of hard to get into if
Yeah.
you don't sort of already have partners in that space. So we'd
Uh-huh.
certainly be down to partner with somebody who is interested in that and develop sort of consumer facing customization tools for architecture. I mean, there's definitely a few companies out there now doing kind of like customer facing tools for doing like modular housing designs, those sorts of things, which I think is pretty interesting. If somebody from that world were to contact us, we could potentially be interested in working on that, even if it's like kind of more practical sort of nuts and bolts work than the kind of conceptual projects that we normally work on. We do also do consulting with other companies, sort of in the realm of taking sort of computational design to digital fabrication workflows. Done a lot of work with New Balance and also other companies, which maybe don't let us tell you their names.
Right.
But that are like less on the artistic side and more sort of for internal design teams to kind of ease the workflow that they have from design to fabrication. So a lot of that kind of work is less about kind of these generative systems or nature inspired design and more about sort of putting the intelligence of whatever fabrication workflows they have into the design tools so that instead of having kind of artistic designers that give their designs to technical designers that then give the design to fabricators, then the fabricators have feedback, and then it goes sort of through these long cycles of people talking to each other, giving sort of the artistic team tools that can directly go to fabricators to sort of make those lines of communication easier and faster.
Sure. Yeah, well, so I can imagine that might have been part of the frustration working with Frank Gehry was now you have to figure out how to make some kind of crumpled up napkin into a 500-story building. But
yeah, well, I know Dennis Sheldon, who was the head of Gehry Tech, was always more interested in doing more of the design work on the computational side rather than kind of just putting out fires using these tools.
But I can see, like, for example, I think we were talking about, essentially you're creating a forgive me for saying this in such non-technical terms, but you're creating some kind of like block of 3D geometry in a in kind of a blank space, right? And then you create your own parameters, your own computational constraints around that, and then it sort of materializes some form of geometric shape, whether that's like in a 2D plane or a 3D space, and then you guys sort of custom develop what those constraints and parameters are going to be. Is it in general, right? Is that kind of, but I guess what I was saying is, like, for example, that you guys do some super sophisticated 3D printing, and it seemed to me that you were able to actually build in the parameters what kind of scaffolding would be needed to actually print it. And that was sort of baked into the computation. Is that right? So that it's actually fabricatable from the beginning.
Yeah, I mean, everything works kind of in multiple ways. So there's sort of the upfront concept of kind of thinking about structures that whose sort of logic naturally makes them self-supporting and printable. And then there's other tools that we've developed kind of on the backside of like taking designs and modifying them in minimal ways to sort of remove overhangs and add support, but in ways that are kind of like organic and meld with the design system that we're working with. And everything kind of has, every project, you know, there's maybe different tensions or needs that need to be addressed, where, you know, where do you want to put your effort? So if you're making something and you're going to only make one of it, you don't necessarily need to think too much about kind of optimizing your workflow to make sure that it is makeable and requires no kind of manual intervention to make it something that is fabricatable. But then, you know, if you want to start making 100 things that are all one of a kind, then you have to start thinking about baking in that fabrication logic so that everyone can go, you know, straight to the printer without a lot of manual work.
Yeah, sure. Well, I think that's amazing that, you know, if you do this correctly, you can really create unique, you know, objects that are very scalable on a very scalable level.
Yeah, I mean, even just from the sort of like very bare bones, you know, or the sort of basic level of making things, of like one of the things that we added to our custom creation tools on our website is just like automatically adding a loop with a tag that has a number on it to track things. So it's like when you're only making a few things, we don't really need that. You can just sort of manually track customers' orders as they come in. And then when you get to a certain volume, just like adding these little automation tools removes a lot of overhead, sort of logistical work.
Yeah. Well, what's an example of something you wanted to model that you came up with an incredible thing in your modeling system, and then was very challenging to fabricate?
I mean, right now, the sort of sculptural projects we're working on, we're spending a lot of time kind of figuring out the best ways of fabricating those, and it's gotten very complicated. So we have that sculpture in the Albany airport we were talking about that's made of these riveted panels. We're working on a version of that that is made of multiple layers of material, both for structural reasons and sort of aesthetic reasons. And sort of one kind of interesting aspect of the way the system works, about this is getting a little bit in the weeds, but we'll go for it, is, you know, unlike a lot of work that's about sort of taking complex three-dimensional shapes and making them out of flat panels, instead of kind of trying to make developable forms, which are forms that can be unrolled into flat pieces without any distortion, we're sort of taking a 3D shape and cutting it into approximately developable panels and then flattening them. And then there's a small, like 1% of distortion when we flatten those panels. And then when we put it back together, that distortion is pretty minimal. You don't notice it very much. It doesn't really affect the overall form. But when you're making something out of multiple layers, those two layers have to correspond. So a small amount of distortion in between these layers, if that distortion is different and they have to
Oh
meet
yeah,
up in a specific way, suddenly that small amount of distortion does become a problem.
I see. Yeah.
So part of the workflow we're developing there is to take these, design these panels digitally, and then sort of digitally simulate them and reconstruct them in 3D as their flattened forms to see kind of what is the approximate resulting shape when we redo the assembly, and then build the next layers on top of those sort of already distorted shapes so that their distortion in the flat pieces will then correspond to each other. So it becomes kind of a very, very intricate, complex workflow of kind of multiple layers of design and simulation.
Yeah.
That ultimately we then have to, make physical prototypes to make sure that all of these concepts actually work the way that we anticipate they're going to work.
Right. Well, I mean, I guess that's the whole magic trick there, is that they see this incredible 3D, amazing, organic 3D shape. And I imagine that you guys design the shape in 3D first, and then you fall in love with the shape, and then you figure out how to fabricate it. But it has to go from 3D to 2D and then back to 3D again. And I think I didn't really think about that too much before I started talking to you about it. So suppose that's the real challenge. Do you feel like architecture is ready to embrace generative systems, or is that? I mean, it seems like there's definitely some trends in architecture that are going that way, but is that you see that you feel like that's still kind of in the margins?
I mean, sort of everything in architecture is kind of in the margins, everything interesting, because the vast majority of architecture that is built is, the most minimal, cheapest buildings that you can build, and is still, just like stick framing,
Sure.
putting drywall up, etc.
Yeah.
There's always been pretty interesting work going on in architecture in the computational space, even in the days when it was sort of looked down upon as being kind of whatever, destroying the hand of the artist or whatever.
Right.
Sort of critical theory people want to apply to things.
Yeah.
But I mean, there's lots of interesting work going on now in sort of generative architecture. How much the real world impacts are, I don't really know. And there's certainly tons of work in the more concrete space of what you work on, building information modeling and sort of fabrication workflows and using computational tools to automate those. And then there's sort of the other side of things, of people doing, 3D printed concrete architecture these days. And certainly a lot of architects experimenting with, generative AI tools, which sounds kind of like a nightmare to me. When I worked at GT, the meme was, Maya blobitecture. and people just sort of sculpting some random shape in Maya and then winning some architecture contest and then
Yeah,
being like, now figure out how to make this.
right,
Now,
exactly.
now it's even worse, is you could generate just images from some, text prompt concept, and then somebody will be like, yeah, now make that. That's even further from a makeable object at this point.
Yeah. Well, no, I mean, I was talking to someone else the other day about, just kind of like you guys are putting in your own constraints into whatever code you're developing to generate these forms. He was talking about the very real constraints that they have to deal with in terms of like all the different zoning regulations and all the different layers of restraints that they have on what they actually can build, which in some parts of urban environments in America are incredibly restrictive. So it's always like they just feed that into the AI and say, okay, well, what can we get away with, but it does scare me how enamored people are getting of this, because it does. But it'll be interesting to see.
Yeah, I mean, I feel like in some ways people might associate our work with that kind of work. I mean, now the word generative has sort of been taken over by AI stuff, but
Yeah.
or like sort of high concept blob texture, similar sort of vein. But in some ways, I feel like the way that we approach our work is kind of the opposite, because usually what we're doing is we've figured out how we want to make something from the beginning. We have sort of a workflow and a fabrication scheme in mind when we're developing a system, so that when we actually generate designs and are generating unique, thousands of unique things or something made of hundreds of unique panels, we already know how we're planning to put it together. So even though we're making these things that are maybe very complex or seemingly sort of abstract and high concept, they're sort of grounded in these sort of fabrication logics where we've sort of put the upfront work ahead of time to sort of make sure that what we're creating is practically fabricatable in an efficient manner.
Yeah.
And that's sort of part of, I think, what makes what we're doing work, is that we're not just sort of saying like, generate some crazy organic tree and then figure out how you can make it after the fact. We're sort of saying, create a system that can generate a tree that is fabricatable.
Right.
And then you have a lot of freedom to sort of explore form, because you don't have to worry as much about like, is the thing you're making make any sense at all?
Yeah,
That's
exactly.
baked into the system.
Right. Well, those principles exist in nature too. I mean, nothing would grow or evolve if it wasn't, couldn't support itself, right?
Yeah, but unfortunately, we can't make things quite the same way that
Yeah.
nature can.
Yeah. So, well, I mean, look, we're going into this incredible technological explosion over the next 5 years with all this new stuff we can do now with computing and AI and everything. What are you looking forward to in the next 5 years or so? What kind of new frontiers you've already really pushed the envelope so far in terms of what can actually be designed and fabricated? But I mean, what other frontiers are out there for you that you're looking forward to?
Good question. I mean, directly what we're working on that I'm excited about is these sort of 3D printed human tissue projects.
Mm-hmm.
And sort of, I feel like there's been this sort of kind of hype cycle that you see a lot in technology and 3D printing specifically, of like, oh, we're going to have 3D printed organs in the next 5 years or whatever, and it's always 5 years from now.
Yeah.
But I do think there has been a lot of innovation on the printing side in the last few years, which is getting us closer to that being a reality in terms of potentially making things that could actually be implanted in humans.
Wow.
Though the progress on that may have gotten slowed a little bit in recent times. On more of the architecture side, I don't know. I mean, there is sort of what sort of AI has done is made an explosion in computing resources that are available. Whether or not the AI tools that exist now are actually applicable to design and architecture, I don't know about that, but I do think that there is a lot of potential for making powerful tools that can leverage sort of the amount of computation available now to make things that are more interactive and sort of user focused. That's one of the things that I've been working on lately, is making sort of some of the systems that we've made that are sort of more computationally heavy running on these like high-end GPUs so that they become fast enough to be interactive tools.
Right. Well, I mean, it's mind-blowing to think what's going to be available, and I really hope to see you plugging in as much as you can, because some just incredible, gorgeous design from you and your partner, Jessica. So anyway, thank you so much for joining today, Jesse, and really looking forward to seeing what else is coming out of Nervous System. So please check out Jesse and his partner, Jessica Rosenkrantz, have their company Nervous System, and you can keep up with all their designs, and you can even buy jewelry and puzzles and all kinds of cool stuff there. Thank you so much for joining today, Jesse. Looking forward to catching up with you soon.
Yeah, thanks for having me. It was a pleasure.
Yeah, it was great. And great to hear about just the intersection of design and code and culture. And looking forward to staying in touch. Take care. Have a good one. This is V.O. and Bush from the Practice Forward podcast, and we'll see you next time.